Welcome back. There's the agenda. Term papers due Thursday. I sent you an email last week. Send it on bspace. Bring a hard copy to class. What else? Any other things before we dive in? Is this the last set of material notes for final, or is there more to come? There's what we've got this week and next, right? So we've got today, Thursday, and next Tuesday and Thursday. Yeah. So 4 more, including this one. I know. Then it's all over. Then you graduate and go away. I don't know for sure. Any questions? Or you don't graduate and come back. One of the two. Or you do graduate and come back. All of these are possibilities. It's a matrix. Graduate, don't graduate, come back, don't come back. All right, here we go. Productivity growth. Productivity growth that we were looking at on Thursday. Just to remind you what we were doing. Here's the graph. Shows you productivity growth rate 1961 to 2012. Those are 5-year moving averages, so it smooths out all the ups and downs that you get when you look at the annual data. But there's still some interesting trends to consider, even though, excuse me, even though there's an awful lot of fluctuation, even with the 5-year moving average. The trends to consider are seen more clearly in this graph, which you also saw last time at the very end. And this graph is showing in each of those boxes what's the average rate of growth of productivity over that period. So in the 1960s, we had an average rate of productivity growth of 2.8%, 1.5% then in the 2 decades following that, the mid-70s to the mid-90s. And then we had the period during which Styro wrote the article and during which economists were very excited, the resurgence period, which is here. Well, that's not what I want to do. Pen. There. Which is here labeled as 1995 to 2004, when the trend rate of productivity growth was 3.5%, or 3.3%. So this was a huge surge. And the questions had been, for a long time, actually since about 1975, the question in the economics literature had been, why has productivity growth slowed down? So why, after having this 1960 to early 70 period where we had, give or take, around 3% productivity growth, why then was there such a decline in the rate at which productivity was growing? And particularly people were very concerned by this piece here, where from the early 1970 to 1980, and remember this is the 5-year moving average, but you can still see it as well in the annual data, when the productivity growth rate was clearly going down. And so by 1980 you had very concerned economists worried about what was going on. Why is output per worker not growing very quickly? A slow growth of output per worker translates to a slow growth of income per capita. A slow growth of income per capita makes people really worried about social policy and economic programs, because if you give more to somebody else and you have very slow growth, giving more to someone else means giving less to another group, as opposed to in a world in which the economy is growing very quickly, you can give everybody a little bit, you can get some people a little bit more and some people a lot more, and everybody has more and everybody's happy. And so there's quite a bit of literature that looks at the slowdown. Now, the bottom line of all of this literature that looks at why did the productivity growth rate slow down is they don't know. So I'm going to show you the possible explanations. We're going to shoot holes in all the possible explanations. And economists never figured out with any sort of consensus view what caused the productivity growth slowdown from the mid-70s to the mid-90s. But then when it started to appear, starting in the early to mid-90s, when it started to appear that productivity growth was turning around and that we were going into this revival where productivity growth was going to be even stronger than it had been in the 1960s, we kind of reached the point where economists said, well, don't know what was wrong. Everything seems to be better now, so let's just go with that. It would be nice to have some sort of consensus view of what caused the downturn in productivity growth, mid-70s to mid-90s, but here's where we are. All right, thing to keep in mind, we're not talking about declines in output per worker, we're talking about declines in the rate of growth. So over this whole period, Y over L, output per worker, which is our measure of average labor productivity, is increasing. The question is it increasing at a 3% rate per year, at a 1% rate per year, at something in between? So how quickly is productivity growth going up? So when we talk about the productivity growth slowdown, we're talking about that the rate of change of Y over L, output per worker, is now 1% instead of 3%, so that rate of change has gotten smaller. Sociological explanations. So one set of explanations that people offered were what are called sociological explanations, and these were basically that people chose to lower their labor productivity. So output per worker, labor productivity, how much output does a worker produce in an hour? And some of these sociological explanations would be tied to tax rates, and so you had the explanation that people were really mad about how high taxes were, and therefore they chose to slow down on the job. Didn't go anywhere, doesn't hold up to the evidence, isn't consistent with the worldwide pattern, isn't consistent with what's happened with tax rates over time, doesn't seem to have any evidence to support it, but nevertheless there you have an explanation that was floated, which was this was all about people choosing to lower their productivity, and so if we could just somehow inspire people to work harder, that would raise labor productivity. Another explanation that was floated was that the slowdown in productivity growth was all about changes in the labor force. It's the women. So the fact that the labor force was changing over the early 1970s, we had a big rise, as we'll see later on today, particularly in white married women's labor force participation rates. Generally, people would say we had an increase in women's labor force participation rates, but as I'll show you later today, it's primarily an increase in married white women's labor force participation. And so the labor force was shifting. There's also the baby boom. So remember, the baby boom is 1946 and 1964, and so you get to 1973, and the leading edge of your baby boom, oh God, do the math, 73 minus 46 would make them 26, 27 years old. So the leading edge of the baby boom is going into the workforce in the early 1970s, and so people said, well, you know, it's those youth. You just can't, all those people who are 18, 19, 20, 21, 22 years old, you just can't go by them because they're lazy and they're not going to work very hard and they're going to be lower productivity workers. You should take offense to that explanation. And they said the same thing about women, so that women weren't going to work very hard because they were mostly, especially if it's married women going to labor force, they're going to be all worried about their kids and they can't focus on what they're doing. And so the entry of women into the labor force and the entry of more youth into the labor force, that's going to lower productivity because people just aren't going to work very hard. Also doesn't stand up to empirical evidence, although it was a very popular explanation for why the productivity growth rate was slowing down. So another explanation had to do with how much research and development expenditure there was. So how much spending was going on research and development. That maybe the slowdown from the mid-70s to the mid-90s was because we just weren't putting enough money into research and development. This is an argument that tended to come about from looking at only part of the R&D spending. So if you look at research and development or R&D spending that's funded by the federal government, indeed there has been a precipitous decline in the federally funded R&D. So in the 1960s, lots of Department of Defense grants, lots of National Science Foundation grants that were going to basic research. All around the country, at universities, at think tanks, and so on. And certainly the federal funding for the National Science Foundation, for Department of Defense grants, as well as for things like National Institutes for Health and the National NEA, National Endowment for the Arts and the Humanities, and all of these nationally federally funded grants have been declining relative to the economy, and you can see that in the line, what color is it, the blue line on the graph. But if we're concerned about R&D funding and the role of research and development in boosting productivity, we shouldn't really care who's paying for that R&D. That it should be that the R&D, whether it's federally funded or whether it's privately funded, that's what matters. And so it's really this top line here, the total amount of R&D funding, that should be relevant to an explanation that links R&D funding to productivity. And there you do see a decline here that runs till 1980. But after that, you see it come back, and it's been pretty stable since then. But the productivity doesn't line up very well with that R&D funding up here.
So why are we assuming that R&D leads to high productivity?
Why are we assuming R&D leads to higher productivity? It's a good question. Because the notion is that the research and development is ultimately coming up with capital that makes workers more productive. How much of that is true? I have no idea. Yeah. I don't know. Yeah.
Even if the industry amount is going up, is it possible like industry R&D is spent on things that are R&D pieces, or that the industry R&D is totally bigger, but it's chopped into small pieces? So like, you know, like
Interesting point. So that you get economies of scale from the federally funded R&D that you don't get from the industry funded R&D. That's an interesting idea.
Like the separate idea of like perhaps choosing different things.
Yeah, I didn't update the other graph because I couldn't find the updated data. I had another graph that showed basic research versus applied research, and there's no perceptible trend in those two things. But the point about whether or not the size of the project and whether there's some economies of scale is an interesting question. I don't know the answer. Okay, what's another explanation? Another explanation was oil. So another thing that people said was, oh, it must all be oil. And the oil price increases that began in 1973, although there wasn't always a very good explanation for how oil would be linked to the slowdown in productivity growth. It could be that the increase in oil prices led businesses to try to reallocate their investment spending away from machinery that would enhance labor productivity and toward machinery that would enhance energy productivity. So in that sense, it's kind of a parallel to what we talked about with the industrial era of the Industrial Revolution, the beginnings of industrialization in this country, when the comparisons between the U.S. and particularly the United Kingdom didn't work very well until you considered not just labor and capital, but labor and capital and energy. And that the United States, because it has so much energy, was so energy abundant in the 19th century, had created capital that was very energy wasteful, but was improving labor productivity. And this is sort of taking that explanation and turning it sideways or on its head and saying, so now we reach a point in the mid-1970s when energy becomes so expensive that now the development of capital is going to be capital that preserves energy, so it increases energy productivity, but doesn't do diddly for labor productivity. So that was an argument that was pretty persuasive to people, particularly between 1973 and say 1979 or 80 or so, when oil prices were quite high. The picture on the left is the oil price relative to the producer price index. So I didn't want to just give you the oil price because that doesn't tell you anything until we make it relative to something else. And so I took the spot oil price and just divided it by the PPI. The PPI is the producer's equivalent of the CPI. So the CPI is the consumer price index, so it's a number that measures the average price of things bought by consumers. The PPI is the producer price index. It's a number that measures the average price of things bought by businesses, producers. And you can see the first surge here when the oil price controls came off in the early 1970s and the price goes way up. You can see the second spike here, 79, 80, 81 in the oil price. And then oil prices start to go down. And then, of course, we had the more recent experiences that we had in 2008 when oil prices went up and then came back down. Our first experiences, as you recall, with $4 and $5 a gallon gas. So what I did in the chart on the right was I just looked at what's the change in the productivity growth rate relative to the price of oil. So if the argument is that when oil prices are let me split my glasses on, make sure I'm looking at this right. That the argument is that when oil prices are really high, that's going to lead to types of investment that lower productivity, then you should have a negative slope here, where the higher, whoops, sorry, my bad, that's a positive slope. The words were right, the hand was wrong. It's because the hand was drawn in by the graph. You should have a negative slope here, where the higher the oil price down here, the lower the rate of productivity growth. But take a line out and just look at it. There's not a whole lot of correlation there, right? So I did fit a line to that, and I have no recollection whether, because I did it last week. I don't remember whether the slope was positive or negative. It doesn't really matter because it was completely statistically insignificant. There's nothing going on there. There's no these dots are not all gathered around some sort of relationship. So that's an explanation that people liked a lot in the 1970s and into the early 1980s, but it doesn't seem to bear out when you look at the whole period from this data is from in the right is from 1973 to the present. What about the mix of Baruch? Not for long. Right, they were long lines, not for long. I mean, it was for a couple months. Where's your question? Go ahead. So the long lines at gas stations lasted for a couple months. It was not for years on end. It was particularly in the spring of my, I think, senior year of high school, junior or senior year of high school. I don't know. I had my driver's license, and I went into school, and there was a short line, and I said to my math teacher, hey, Ned, do you want to go get you some gas? There's only 4 cars in line. So I skipped math class and went and got gas for him. It was, specialization trade. Worked out all around. But the lines were only a couple months long. So yeah, people may have had trouble, but it wasn't like this didn't last for years and years and years. Lasted long enough that all of us who lived through it have stories to tell, and that was when you were a 16, 17, 18-year-old at home. Now your chore became going and taking the car to get gas, because it could take 2 hours to get gas, and so that was, my fault. I don't think my dad filled up his tank. That was my job, except my dad didn't trust me driving his car, but so probably brought my brother back from the Marines to do it or something. Okay, one more shot. What about the mix of output? So we looked at the rise of services, and when we look at this first graph that I showed you, whoops, wrong place. In the graph, go to slide, let's smooth that out a little bit. In the graph, I drew out manufacturing as opposed to non-farm business so that we could see what's going on with the productivity growth rate of manufacturing as separate from everything which is non-farm business. It would be wonderful if the Bureau of Labor Statistics that produces this data were also to produce a number which is the rate of growth of productivity in the production of services, but they don't. So they produce and publish a number that's the rate of growth of productivity in manufacturing. They produce a number which is the rate of growth of productivity in non-farm business. And so you can sort of look at it and say, well, non-farm business includes manufacturing and everything else. If manufacturing is above non-farm business, then non-farm business minus manufacturing must be below it for this thing to be the average. So what I did in this next slide was to look at the mix of output and see whether or not we can get anything out of the rise of services over time in trying to explain the slowdown in productivity growth. So this is from the table from last time. It just gives you the 5-year averages of the productivity growth rates. And one of the things that I want you to pick out from this is that throughout this period of the slowdown, so the slowdown is really shown here. This is the slowdown. Throughout the period of the slowdown in the productivity growth rate for non-farm business, look what's happening to productivity in the manufacturing sector. It's really not changing. So it's averaging 2.7, 2.7, 2.7, 2.8. It dips down to 2.3 for that period 1990 to 94. It surges back to 4.7 and 4.4 in the mid-90s and the mid-aughts. So what I did was I took the share of output that is services, excuse me, I took the share of output that is manufacturing. Forgot what I was doing. I took the share of output that is manufacturing, and I multiplied that by the manufacturing productivity growth, because the overall non-farm business productivity growth ought to be a weighted average. So it ought to be that if I take manufacturing as a share of GDP and multiply that by the labor productivity growth in manufacturing, and I add to that the non-manufacturing, so everything but manufacturing as a share of GDP, and multiply that by output per worker for the non-manufacturing, that weighted average ought to equal this column that's non-farm business. So non-farm business ought to be the result of this weighted average of the productivity growth rates of manufacturing and the productivity growth rates of everything else. Manipulate that equation a little bit, and what you can do is you can then pull out of there what's the productivity growth rate for the non-manufacturing piece. And so that's what I do here. So what's here is this is taking the overall productivity growth for non-farm business and breaking it into its two parts. The part that's attributable to the manufacturing growth rate for manufacturing, the productivity growth rate for manufacturing, I said that wrong, didn't I? The part that's attributable to the productivity growth rate for manufacturing, and the part, the part that's attributable to the productivity growth rate for everything else. What do you see? So there's the manufacturing, the big red line, there's everything else. If you wanted to find an explanation for why productivity growth overall has slowed down in the mid-70s to the mid-90s and then surged in the mid-90s to the mid-aughts, would you look at manufacturing for your answer? No. That the swings in productivity growth are not coming from the red line. The red line, which is manufacturing's contribution to overall productivity growth rate, stays pretty tightly contained in that 0 to 1 band. That it's really swings in the productivity growth rate of everything else that's explaining the slowdown, and then what we're going to look at now is the resurgence in productivity growth. There's a thesis topic for you. So this is another one. So for years I told you I didn't present anything about services and how the rise of services must have contributed to the slowdown in recoveries, and now I'm working on that. And so this is another piece that I've been saying for years, and somebody else can pick it up, or maybe I will in a few years. I think it's right. I don't have any proof yet, but I think it's right. Okay. So what did we figure out? Nothing. What can I say? We didn't figure it out. We never figured out why productivity growth rate slowed down, but you know what? It got going faster again, so who cares? It's a speechy. Everything seemed to turn around. Because then, 1995 to 2004, the productivity growth rate increased by almost 3.5%, so 3.3% average over that 10-year period. And oh my gosh, I mean, economists, as excited as people are this week and last week about the critique of Rogoff and Reinhardt's article, the critique of Rogoff and Reinhardt's article, people were so excited. 2000, 2001, 2002, you go to the Annual Economics Association meetings, which is a place that, you know, it's a frightening place to go. There's 5,000 economists running around all in a few hotels. There's a lot of graduate students there who are on the job market, so they're just sort of exuding stress. They sort of walk by, and it's sort of like, you know, the bubbles that would surround cartoon characters are just stress as they walk along. And so economists are weird people. We get excited about weird things. You know, everybody's about this Rogoff and Reinhardt thing. And at the meetings 2000, 2001, the big panels that everybody, you know, 2,000 people wanted to go to these panels and hear what people were saying were about the resurgence in productivity growth, how the productivity growth slowdown had been an aberration, how it was this 20 years of horrid pain, but it's over. We don't have to go back. We're never going back again. We don't really know what happened. But anyway, we're not going back again. Everything is wonderful. Let's bring on the band, and so on. And the general takeaway from all of those sessions was that the resurgence was due to information technology, computers. The world has continued going on. The world didn't end in 2001. People thought it would, but it didn't. And now we see that the overall average for 1995 to 2012 is only 2.4%. That's still better than what we had in the mid-70s to the mid-90s, but it's not as bring in the bandish as what we thought we were going to see when we had these meetings in 2001, 2002. So, all right, why the resurgence? So, the consensus is information technology, IT. And the graph here, which is in last week's handout, shows you IT share total investment. That's using the axis on the top part, and IT share of GDP, which is showing you the axis on the bottom part, or which is using the axis on the bottom part. And in both of those, you can see that there's a big increase in IT. So, yeah, IT, computers, everything with a chip in it is IT. Not everything? Oh, Lord Almighty. Yeah, that's right. Cars are now computers on wheels. So, yeah, computers. I don't know. Let's just call it IT, and let's have this vague definition of IT. So, computers and other stuff that in the good old days would have easily been categorized as computers, and now there are things like cars that are computers on wheels, and so who knows anymore. Okay, so IT share total investment goes up to almost 30%. Oops, hits a little peak there in 2000, doesn't it? And IT share of GDP also surges, particularly here in the 1990s. Now, these meetings I was telling you about, 5,000 economists running around being excited about things that you think, are you serious, really? These meetings were taking place right about here. And so, and I can put my thumb over it, but you can't tell if I put my thumb over it. Let me see if I can do white ink. Ink color, white. Oh, God, I'm more clever than I realized. Okay, there. So when all of this conversation was going on, when Styro was writing his article, the IT share of total investment looks like the line at the top. You don't see the decline that's coming, right? They don't know what's coming in the future. And so they think this thing's just going to keep going up and up and up. It's really fabulous. Well, in fact, it didn't. And the IT share of total investment starts to come down. Partly, what year were you guys born? 90? 91, 92. So going into 2000, there was the Y2K bug, which some of you may have known about, and hopefully most of you were oblivious. And the notion was that all computers were supposed to stop working on January 1st, 2000. And the idea was that when the brilliant engineers who had designed computers, they had designed them with a month, day, year way of keeping track of the calendar. And so when you go from 12/31/99 to January 1st, 2000, you're actually, the computer's going to think that you're going from 12/31/1999 to January 1st, 1900. And so they said, all the computers in the world are going to croak at midnight on December 31st. Now, it's always sort of a strange thing. I mean, couldn't you test this by like resetting the date? You guys, I mean, everybody knows how to reset the date on their computer to see what happens, right? I did that paper last week. See the date stamp there, right? We know how to do that one too. So yeah, we can change the date and test these things, but nevertheless, there was this the whole world's going to end. All the computers are going to die. Everybody has to replace all of their computers.